let me give you some context by revisiting the system of equations we had from our last session, the linear programming problem. Remember the objective function and the constraints? So I'm just going to copy those constraints. And this is what we had before. Now, if we, the way we found the roots of these constraints was through classical algebra, right? Move this term to the right side, move that term to this side. And then, you know what algebra is about. It's about it's about simplifying it, right? Cancelling from both sides, adding to both sides, reducing from both sides, dividing, etc. Gaussian elimination allows us to solve for the roots, but without having to move the terms from one side to the next. And it is the stepping stone to get into LU decomposition, which I don't want to say simplifies, but makes the process more efficient. So what we're going to look at is solving systems of equations more efficiently. Anyway, to represent these two inequalities, and of course what we did in the LP problem was to express these as equations. But we would get this matrix. So obviously we would not bring the variables in here. We would know what variables these numbers stand for, because if we follow the order, right? 100x, so this 100 is associated with that x. This 100 is associated with that y, and you get the idea. And the reason I put these parentheses is so that you know that, you know, I did it really for this term. So you know that this is one number. This is one number. Okay. Now this is called an augmented matrix. It's called augmented because this matrix is actually the union of two. The matrix for what's on the left side of the inequalities, and what's on the right side of the inequalities. So augmented matrices would also be denoted like so. You could put a vertical bar. I could put some LaTeX here to space them out a little bit. So let me show you how we would go about solving this system of inequalities with Gaussian elimination. So here, and I'll come back to why I even brought up augmented matrices, because it has to do with LU decomposition. When we do LU decomposition, we separate the terms on the left side of the equation and the terms on the right side of the equation. Okay, so let me get. I'll come back to this idea later. Okay, I'll come back to this. So this is representing inequalities, or even equations for that matter. It doesn't really matter. With or in a system of equations, matrices, in a matrix.